Hello students, this is Sir Murtaza and welcome you to another lecture of physics. So let's start. So first of all, we will look onto the agenda for this lecture video. So in this lecture video, we are going to discuss the following SLOs, and the SLO is solve word problems related to free falling bodies. Okay, so it means that in this lecture video, we will be talking about free falling bodies. Okay, and also we will do some word problems related to free falling bodies. Okay, now first we will talk about free falling bodies, motion of free falling bodies. So in order to understand free falling bodies, drop an object from some height and observe its motion. Does its velocity increase, decrease, or remains constant as it approaches the ground? Okay, then Galileo was the first scientist to notice that all the freely falling objects have the same acceleration independent of their masses. Okay, so what Galileo have noticed is that all the freely falling objects. Okay, what does this mean? Freely falling objects. Freely falling object means that, for example, you take an object and rise it to some height. Okay, as you just release it and the body gets down, so this type of motion is known as the freely falling objects, in which an object is raised to some height and then it is released. Okay, so Galileo was the first scientist to notice that all the freely falling objects have the same acceleration independent of their masses. Okay, whatever its masses is, the object moves with the same acceleration. Okay, then he dropped various objects of different masses from the leaning tower of Pisa. He found that all of them reached the ground at the same time. So what he has done is he dropped various objects of different masses from the leaning tower of Pisa. So he has taken different objects and dropped it from the leaning tower of Pisa. Leaning Tower of Pisa is a tower, and its name is Leaning Tower of Pisa. And what he has found is that all of them reach the ground at the same time. Okay, all of them took the same time to reach the ground. So the acceleration of freely falling bodies is called gravitational acceleration. Okay, so this is known as a gravitational acceleration, the acceleration of freely falling bodies. It is denoted by G. Okay, it is denoted or represented by G. On the surface of the earth, its value is approximately 10 ms minus 2. So the value of acceleration due to gravity is 10 ms minus 2. For bodies falling down freely, G is positive and is negative for bodies moving up. Okay, so we take the value of G as positive if the body is moving from top to bottom. Okay, and the value of G is taken as negative if the body is moving from bottom to top. Okay, then equations of motion for bodies moving under gravity. Okay, so for freely falling bodies, what we do is we use the equations of motion. Okay, but for those equation of motion for freely falling bodies, a little changes is being made. That change is Vf is equal to Vi plus Gt, H is equal to Vit plus half Gt square, and 2Gh is equal to Vf square minus Vi square. So you can very easily notice that what we have done for freely falling bodies is we have replaced A by G. Okay, A is replaced by G, and S, which is the distance, is replaced by H. Okay, so this is the equations of motion for bodies moving under gravity. Now we will do some numerical question. So the question is, a stone is dropped from the top of the tower. The stone hits the ground after 5 seconds. Find, number one is the height of the tower, and the number two is the velocity with which the stone hits the ground. Okay, so in this question, they have said that a stone is dropped from the top of a tower. There is a tower, and the stone is dropped from its top. Now the stone hits the ground after 5 seconds. So it means that the stone took 5 seconds to hit the ground. Now what I have to find is find the height of the tower. We have to find the height of the tower from with which the stone is being dropped, and the velocity with which the stone hits the ground, and the velocity with which the stone hits the ground. So before doing this question, I just want to say you one thing, that whenever an object is being dropped from a height, okay, it means that, for example, this is the height and the stone or a body is dropped from this point. So definitely the body will move in this direction. Okay, so what we have to do is, at the top you have to assume the initial velocity as 0. Okay, this value is being assumed that from the top of a tower the initial velocity is 0 ms minus 1. Okay, so whenever a body is dropped from a height, what we have to do is we have to take the value of initial velocity as 0. Okay, so in the data we will do the same. Initial velocity is taken as 0. In the question, nothing is being said about the initial velocity. But as the stone is dropped from the top of a tower, so we will take its initial velocity as 0 ms minus 1. Then the value of g is constant, which is 10 ms minus 2. Time in the question is being given 5 seconds. In the first part, we have to find the height, and the second part, we have to find its final velocity. Now, for the first part, we will use a second equation of motion. Then what we can do, we have to put all the values. Initial velocity is taken as 0, time is 5, half remains as it is. The value of g is 10 and the time is 5, square remains as it is. Then what we have to do, 5 multiplied by 0 is 0. The square of 5 is 25, 10 remains as it is, half remains as it is. Then by doing little maths, we will find the height as 125 meter. This is very simple maths. You can cancel this 2 ones are 2 and 2 fives are 10. Okay, and then multiply this 5 by 25, so it becomes 125 meter. So the height of the tower is 125 meter. Now we have to find the final velocity. So for the final velocity, the formula we will use is vi plus gt. Vi is 0, g is 10, t is 5. So the final velocity is 50 ms minus 1. So the final velocity is 50. So in this way, we will solve this numerical question. So in this way, we are done with this. Hopefully you have understood. Uh, we'll meet you again very soon in the next lecture video. Till then, Allah Hafiz.